The universe, without a doubt, is one of the most fascinating and mysterious subjects of discussion in science. For centuries, scientists have been exploring and trying to understand the forces that govern the universe. One of the most intriguing theories gaining ground is the holographic principle. It postulates that the universe as we perceive it is nothing but a hologram, a two-dimensional structure that projects an impression of three-dimensional form. At its core, the theory suggests that all the matter and physical processes we observe in the universe have a dual description, one in terms of classical gravitational interactions, and the other in terms of quantum field theory. The holographic principle suggests that the description of the universe on a large scale, gravitational interactions, can be mathematically formulated as a theory of quantum physics at a small scale. Put differently, we can think of the universe as a vast computer that processes information rather than a massive collection of physical objects. The Gateway Project, known formally as the Stargate Project, emerged as a pioneering initiative within the corridors of military and intelligence research. While its primary aim was to investigate the potential military applications of psychic phenomena with remote viewing, its ramifications extended far beyond the realm of espionage. Delving into altered states of consciousness, the project inadvertently unearthed tantalizing glimpses of a deeper reality, one characterized by an intricate energy matrix reminiscent of the toroidal geometry observed in various natural phenomena. This conceptualization posits a universe wherein energy flows in a continuous dance, weaving through space and time, and shaping the very essence of existence. As researchers grappled with the implications of their findings, a profound realization began to emerge: a recognition of the universe as a living, pulsating entity, intricately intertwined with the fabric of consciousness itself. This paradigm shift invites contemplation of our interconnectedness with the cosmos and our capacity to align with its fundamental rhythms. By understanding and harmonizing with this cosmic energy matrix, humanity stands poised to unlock the latent potential within, co-creating a reality imbued with harmony, balance, and infinite possibility. The scientific evidence supporting the holographic principle is compelling. The cosmic microwave background radiation shows evidence of holism, which supports the idea of a shared origin of all things. The black hole entropy link is an important one, as it leads to questions about what happens to information that enters black holes. There is also the question of where the pixels that make up the universe originate. Despite the evidence, there is still a lot we don't know. Discovering the source of the holographic principle may lead us closer to understanding the ultimate nature of reality. So what could be the source of this seemingly otherworldly force? One possibility is that we are living in a simulated reality. This theory argues that our universe is a computer-generated one, and every object and process is a part of the simulation. This theory has gained popularity recently with the advancements in our computer capabilities and the increase in the use of virtual and augmented reality. I mean, who knows what's possible with this technology in, say, 100 years? Another possible source for the holographic principle is the concept of black holes, suggesting that our observable universe is created by a large black hole that projects out a holographic image of the universe as we know it. The hologram is an illusory reality projected by the black hole, and the real universe is within it. The third possibility is that the holographic principle is a unique characteristic of our universe. If the universe originated from the Big Bang, according to the holographic principle, the universe is a projection that is created when space is curved with extreme gravitational force. Thus, it could be a rare aspect of the physical universe that allows for the holographic principle to exist. Another intriguing possibility is the connection between the holographic principle and consciousness. Recent research points to the idea that consciousness creates, or at least is a crucial part of the physical universe. This theory suggests that the universe is a conscious living entity that is creating and recreating itself. The idea of a projected consciousness posits that the universe we experience is a holographic projection generated by our own minds. In this theory, human consciousness is not limited to the physical body, but instead can travel outside the confines of the physical realm and interact with other dimensions. This idea is not new and has long been a part of ancient spiritual beliefs. With science and technology advancing at an unprecedented pace, however, the idea is getting a fresh perspective. To better understand this theory, it is important to first define what a hologram really is. Holography is a photographic technique that records the interference patterns between two or more light waves to generate a three-dimensional image. It works by splitting a laser beam into two parts. One reflects off the object being photographed, and the other, known as the reference beam, bounces off a mirror. When the two beams cross, they create an interference pattern that is captured on photographic film. When viewed under the right lighting conditions, the photograph appears to be a three-dimensional image of the object. Now imagine applying the same principle to the universe. Instead of a laser beam, imagine that our consciousness acts as the reference beam, and the universe as the object being photographed. According to the theory of projected consciousness, the interference patterns created by our conscious minds generate the holographic reality that we experience. As fascinating as this theory is, it raises a host of questions and criticisms. One of the main arguments against this theory of a holographic reality is that it requires a level of complexity in the brain that is not yet fully understood. However, recent studies have shown that the human brain operates in a way similar to a hologram. Additionally, scientists have discovered evidence of error-correcting codes within the fabric of the universe itself, indicative of a hologram. Error-correcting mechanisms in the universe, like quantum error correction codes, ensure information accuracy in complex systems. In theories related to the holographic principle, information is encoded on a boundary for error correction, maintaining coherence in the holographic projection. The implications of a holographic universe are far-reaching and would require a fundamental rethinking of our understanding of consciousness, reality, and the universe itself. It is not inconceivable that the development of advanced virtual reality technology may eventually simulate the holographic reality that projected consciousness suggests we experience. But what would this mean for human consciousness and our relationship to the world around us? Would we be able to control our own reality more? Would we be better able to understand and control our own minds? These are just a few of the questions that the projected consciousness theory raises. Ultimately, the idea of projected consciousness and a holographic reality challenges us to re-examine the very nature of our reality and the limits of human consciousness. While skepticism and criticism are to be expected, the possibility of unlocking the secrets of the universe through a deeper understanding of consciousness and holographic technology cannot be ignored. Moving along to the strange world of quantum entanglement and non-locality. Quantum mechanics, the study of the very small, has led to a number of mind-boggling discoveries over the past century. Among them are the concepts of quantum entanglement and non-locality, which are perhaps the most mysterious and fascinating phenomena in all of physics. Let's explore these concepts in detail and see what implications they may have for our understanding of the universe. Quantum entanglement is a phenomenon where two or more particles become so closely linked that they share a single quantum state between them. This means that any measurements made on one of the particles affects the state of the other particle instantaneously, regardless of the distance between them. While this may seem like a violation of the law of physics, it has been confirmed in countless experiments and is now considered a fundamental feature of the quantum world. First proposed by Albert Einstein, Boris Podolsky and Nathan Rosen, in their famous EPR paper in 1935, they argued that entanglement contradicted the idea of local realism, which holds that physical systems have definite properties that exist independently of measurements. However, quantum entanglement is a non-local phenomenon. It cannot be explained by any classical theory, in which signals cannot travel faster than the speed of light. This is where the concept of non-locality comes in. It refers to the ability of particles to share a quantum state in such a way that their behaviors are correlated even when separated by huge distances. This means that something can happen to one particle and instantly affect its entangled partner no matter where it is located in the universe. One of the most significant demonstrations of non-locality was proposed by physicist John Bell in 1964. Bell's theorem shows that any physical theory based on local realism must make certain predictions that are violated by quantum mechanics. In other words, there are correlations between entangled particles that cannot be explained by any classical theory, no matter how plausible. The implications of entanglement and non-locality are vast and varied. They are the foundation for the field of quantum computing, which promises to transform information processing by harnessing quantum superposition and entanglement. They are also the basis for quantum communication, a technology that allows for secure communication between distant parties using these principles. However, there are still many challenges and limitations to be overcome in order to fully realize the potential of entanglement and non-locality. The measurement problem, where interactions with the environment cause entangled systems to decohere and lose their entanglement, is one major obstacle. Another is the difficulty of generating and maintaining large-scale entangled systems. Another one of the most famous theories in quantum mechanics is Bell's inequality. This theorem laid the foundation for further investigation into the mysterious properties of quantum mechanics. Let's explore this further. As quantum mechanics is the study of the behavior of subatomic particles, such as protons, neutrons, and electrons. Unlike classical mechanics, which operates on an observable level, quantum mechanics delves into the behavior of particles so small they cannot be directly observed. These particles exhibit strange behaviors, such as existing in two places at once, or seemingly communicating instantaneously with other particles, regardless of distance, known as non-locality. Key concepts in quantum mechanics include wave-particle duality, which suggests that particles can exist as both waves and particles simultaneously, and the uncertainty principle, which states that the more we know about the position of a particle, the less we know about its velocity, and vice versa. Bell's inequality is an essential theorem in the field of quantum mechanics that unfurls the significance of non-locality, and the discovery of Bell's inequality has resulted in a broader understanding of the fundamental properties of quantum mechanics, paving the way for the development of new technologies and secure communication methods. It's in demystifying Bell's inequality that we come closer to unlocking the mysteries of the quantum world. Enter the Pauli exclusion principle, a fundamental law in quantum mechanics that defines the behavior of particles with half-integer spin values called fermions. It plays a crucial role in fields like physics, chemistry, and biology, and is essential to the development of nanoscience and technology. Let's provide a comprehensive overview of the principle, including its basics, significance, exceptions, and ongoing research. The Pauli exclusion principle has several implications in the scientific world. In the field of physics, it explains the periodic table and the arrangement of electrons in an atom. In chemistry, the principle is responsible for the chemical behavior of elements, And in biology, the principle is crucial to understanding the structure and function of proteins and macromolecules. Moreover, the principle has significant applications in nanoscience and technology, utilized in the development of electron transistors, which are the building blocks of modern computing devices. The principle also plays a role in the development of semiconductor devices, magnetic materials, and superconducting materials. However, there are some exceptions to the Pauli exclusion principle. Some factors, such as temperature and magnetic fields, can challenge it. For instance, some materials, such as metal, can superconduct, allowing more than 2 electrons to occupy the same state. However, these exceptions are rare and don't have a significant impact on the principle's essential behaviors. Just as the Pauli exclusion principle governs the behavior of subatomic particles, guiding us to understand the intricacies of matter, so too does the gateway experience offer a portal to explore the depths of consciousness, unveiling the mysteries of our inner universe. So what exactly is the gateway experience? It's a method of induced meditation designed to help us reach different levels of consciousness and expanded awareness. It consists of different levels or focuses, each with its own purpose and set of benefits. Starting at focus 10, or mind awake, body asleep, we can eventually progress to focus 12 with expanded awareness, and then to focus 15, characterized by timeless. Moving into focus 21 and beyond. With each focus, we become more and more in tune with our subconscious and more capable of accessing altered states of consciousness. Beyond focus 15, venturing into focus 21, experiencing heightened states of awareness and deeper connections with our subconscious mind. At focus 21, we may encounter expanded perceptions of time and space, facilitating profound insights and intuitive understanding. Moving further along the gateway experience, participants may reach focus 27, where they delve even deeper into the layers of consciousness. At this level, individuals may experience enhanced clarity of thought, heightened sensory perception, and a profound sense of interconnectedness with the universe. Focus 27 offers opportunities for deep self-discovery and spiritual growth, as practitioners explore the vast depths of their inner being and the mysteries of existence. By being open, you allow yourself to connect with the spiritual realm and access entities not commonly perceived in the physical world. The spiritual realm is often described as a world vibrating at a higher frequency, which is why we are unable to see it. However, our consciousness has the capacity to transcend the physical world and enter other realms. Be careful. With each journey into expanded consciousness, we not only discover the depths of our own being, but also contribute to the collective evolution of humanity's understanding of the cosmos. It's not just a leap forward, it's a quantum leap into the very essence of existence itself. Expanding consciousness isn't just about unlocking hidden realms of existence, it's about unleashing the full spectrum of human potential. It's about tapping into creativity beyond imagination, finding resilience in the face of adversity, fostering deeper connections with others, and awakening to the profound beauty of existence. By expanding our consciousness, we not only enrich our lives, but also contribute to the collective evolution of humanity. Humanfluence out.